All right, everyone, we're going to keep things moving along here and move along to part 2. Take some good notes for this. This is based on the homework. Remember in the homework I talked about the Taussman asthma program. And in this particular example, I said I had 3 people who went in the Taussman asthma program. It's a paired t-test because of pre and post and intervention in between. You remove individual differences, which is good. The fact that person 1 starts with a 1, person 3 starts with a 7, doesn't matter. What matters is the relative change. So person 1 goes up 1, person 2 from 4 to a 6 plus 2, person 3 from a 7 to a 10 plus 3. We try to evaluate if that's going to be a significant improvement. We get the means on the first table, 4 and 6. We want the treatment effect to be as large as possible, right? From pre to post. That means my program works even better. It doesn't matter which number you take first. So the numerator for the t-test is going to be a 2. The denominator is that standard error of the mean. How do we want anything that has error in it? We want that to be small. And so we got a 2 over a 0.57. The t obtained score is 3.46. And if you don't know it already, the probability of getting that t-score due to chance is 0.074. So you could get a t result of 3.46 about 7.5% of the time due to chance. Now the problem that we have here is that we have to make a decision if this is a significant improvement or not. 0.074. Well, because 0.074 is more than 0.05, we actually, if we have to do the line in the sand thing, we'd actually have to say, oh, that result is non-significant and the Taussman program doesn't work. The question is, are there any downsides to that decision? So we're making a decision here that the Taussman program doesn't work. But the big question here is whether or not this is correct. So if we actually open our books, and actually I think I put this on the next page, it looks like in both books around page 244 for version 8, 246 for version 9. They actually put these state of affairs tables in for you to kind of have you balance this thing off. So in this situation, and I put it in number 3 here as well, in this particular situation, I collected data, and if you look in my Roman numeral 3, I had a result that was statistically what? Non-significant. So what do I have to decide? Well, I have to decide that my program does not work. So I might be right. The Taussman program may not work. So I might have a correct no decision there. But the other potential risk I run is my program may in fact work, but I may have a type 2 error. I may not be able to actually evaluate things correctly. I might have a type 2 error or miss. My program may in fact really work, but I just don't have enough data to support that contention. So I could have a type 2 error here. And there is reason to believe that this in fact may be the case. Because if you know anything about doing research in statistics, you would have something to say about this issue of how many I have in my sample. If you look in this, how many are in my study? Only 3 people. 3 people is a very small number. And the problem with only having 3 people, and it's right there in these pages as well, if you only have 3 people, you lack something called power. Power is the ability to detect significant differences. Power. And in this particular situation, if I only have 3 people, that is too small of a sample size to detect a significant difference. 3 people is not enough. Look at my degrees of freedom. There are only 2 degrees of freedom. You would never run a study with just 3 people. In this case, I ran 3 people in my study. I got a result that was not quite significant, and the reason that I'm going to have probably a type 2 error here is because I didn't have enough power. My sample size was too low. If I have actually a sample size much larger than this, or even twice this size, the standard error of the mean is probably going to be a lot smaller, and therefore I'll probably be significant. So this is clearly a case where you only run 3 people, you don't have enough power, and so this result, if you decide that this result is non-significant, which 0.074 is, then you're going to have to come to the conclusion that you don't have anything here, but this would be a problem with power. You probably have a type 2 error here. What any statistician would tell you you need to do is actually you need to have more people in your sample. So we want more power. We don't have it here, and hopefully by running more people that would occur.